All right, this last video is just going to be kind of what I did 2 weeks ago, where we just kind of look at some of the problems. I'm not going to write out all the answers. You see the answers on the answer key that I uploaded and did this morning. But I just want to talk about these problems. So the first one says a political scientist is surveying 28 out of 106 representatives in a state's Congress. So 106 representatives total. We're not asking all of them. That would be a census. We're asking 28 of them. And of those 28, 14 said they were supporting a new education bill, 12 said they weren't, and 2 are undecided. So what's the population of this survey? Population is the whole. It's everybody that we care about. It's the 106 representatives. So the size of the population is 106. All the representatives in that Congress, that's our population. So the size of the sample is much smaller. The size of the sample will always be less than the size of the population. It'll be, unless you're doing a census, right? Size of the sample is just 28. Give the sample statistic. Remember, statistic is the data from the sample, and parameter is the data from the whole population. So give the sample statistic for the proportion of voters surveyed who said they were supporting the education bill. What's that statistic? Well, 14 said they were supporting it out of 28 polled. The sample statistic would be 14 out of 28, which simplifies to 1/2 or 50%. And based on this sample, we might expect how many representatives to support the education bill, provided there's no sampling bias. So if about half the people that we surveyed support it, then maybe half of the total people support it. So yeah, maybe 53 representatives, or half of them, however you phrase it. 53 is probably better, but that's basically what we're doing. Identify the most relevant source of bias for a survey that asks the following. Should the mall prohibit loud and annoying rock music in clothing stores catering to teenagers? There's a little bias here. Right here. Right? So, it's a leading question. It's a loaded question. There's phrasing in the question that's trying to influence your response. Yeah, you don't need to write annoying. You could even just get rid of that and say loud, and it'd be a lot better. Loud still kind of has negative connotations, but it's better. Look at number 9. You ask the students, in a study, you ask the subjects their age in years. Is this qualitative or quantitative? The age in years is going to be a number, but remember, number doesn't necessarily mean quantitative. But it starts you in the right direction. Because if it's not a number, it's qualitative. So it's a number. So we think it might be quantitative. Can we do meaningful things with these numbers? Yes, I'm twice as old as somebody else. Oh yeah, he's 5 years older than me. We can add, subtract, all these things with these numbers and it still makes sense. So yes, it's quantitative. Just watch out for that. Let's look at 11. Does this describe an observational study or an experiment? The temperature on randomly selected days throughout the years was measured. If all we're doing is just observing or recording data without changing anything or treating anything, it's an observational study. So this was an observational study. In a study, the sample is chosen by separating all cars by size and then selecting 10 from each size grouping. What's the sampling method? So again, whenever we group or separate, that's, you think stratified or cluster, or maybe quota. Cluster is choosing a couple groups and then doing everyone in those groups, whereas stratified is choosing some from each group. So this is going to be stratified. Last one I want to look at is number 15. A team of researchers is testing the effectiveness of a new HPV vaccine. They randomly divide, this is important, we didn't talk about this, but it's important, randomly dividing. The researcher is not choosing who they want in which group. And group 1 gets the new vaccine, group 2 gets the existing vaccine. The patients don't know whether they get in the new or the old. The treatment group, so you might say they're both being treated, right? Group 1 is getting the new one, and group 2 is getting the old one. But when we say treatment group, we mean treatment as in, what are we measuring the effect of? What are we trying to change? What's the new thing? So it is just group 1 for the treatment group. The control group is group 2. They're getting, that's the baseline. Is it blind or double blind? It is blind because the patients in the study do not know which group they're in, but there's no mention about whether the researchers know or not. So we're going to assume that the researchers do know which group each patient is in. So at the end, is this, and this last one is not very important. I think I skipped it in the answers. Is this best described as an experiment, a controlled experiment, or a placebo-controlled experiment? So I would say that it's a controlled experiment. There is a control, but there's not really a placebo. Okay, it's not like if group 2 received like a saline solution instead of a vaccine, that would be a placebo. But they are getting something real. Okay, so there's no placebo here. We'd say a controlled experiment. So that's kind of some of the homework problems. Try to do this again next week. We'll see. Good luck. Bye-bye.